Hi folks, welcome back. I hope you're all doing well. So today I want to take a look at a paper from the 2021 International Conference on Software Engineering, and it has this really colorful title, Siri, Write the Next Method. And what it tries to do is extend the notion of autocomplete from just the next token or next few tokens that a programmer is trying to write to the entire next method. And I'll spoil the ending by saying that the results are not great, but it is a cool and interesting idea to explore nonetheless, which is why I wanted to cover this paper. The system they've built is called FEARS, and they haven't really specified what that acronym means anywhere in the paper, but we'll just call it that. And what it does is look at implementation patterns from a large number of open source Android apps. They looked at about 20,000 Android apps. And from that vast data set, they've extracted sets of methods that usually go together. So they look at commits to identify new methods that are usually implemented together. And they want to build a model out of that, where if we see one method, we can then say that it is likely to be followed by the implementation of another method. They call the first method, the one you've already seen, the left-hand side, and the next method, the one you're predicting, the right-hand side. This is the overall structure of the system. They take all these apps from GitHub and they focus just on Android apps written in Java, and they pass it through a Java parser so that they can get the underlying structure from the source code. And then they perform clustering on the resulting methods extracted from every Java class. They use an existing clone detector called Asia to group similar methods together and form clusters with them. And finally use a well-known data mining technique called association rule mining to then build lists of these left-hand sides and right-hand sides, which can predict a likely method to come next given a few existing ones. And finally, the resulting model is exposed in the IDE in Android Studio via a plugin created by the authors. This plugin is able to recommend methods to insert next given methods that it has already found in the file that you're looking at. There is a sensitivity setting up here. What low sensitivity means is that the system generates fewer but higher quality recommendations. And the converse is, if you set the sensitivity too high, you'll get more recommendations, but you might have to sift through them to find a good one. So obviously the question is, how good are these recommendations? Would they actually recommend a method that the human programmer would have written next? And in order to answer that, they construct this study. Now, this is still a synthetic study. They didn't actually get to use this on real human programmers, which is one of their major areas for future work. But what they do is they break their data into 3 buckets. 80% is their major training set, and then they use 10% as validation for tuning parameters. And finally, they hold back the remaining 10% as a test set. And it is this test set data that they use to get evaluation metric. And for models like this, we usually look at metrics like recall and precision, where recall measures the number of commits for which the system generated at least one correct recommendation. And note that the correct recommendation does not have to be an exact match, but just close enough. And this really is one of the key metrics to look at, because this tells you in what fraction of commits FEARS could be potentially useful. Precision is the fraction of commits that the system gets right. So it's the correct recommendations over the total number of recommendations. And what they found was that on the lowest sensitivity setting, remember that low sensitivity means that the system tries to generate a small number of high quality recommendations. The recall was only about 4% with precision being 72%, whereas on the high sensitivity setting, recall was 7% and precision was down to 50%. But the big caveat with these figures was that a lot of the recommendations were for very small methods, small and trivial methods like getters and setters. So they reran the numbers to exclude short methods, and they only looked at methods longer than 4 lines. And recall takes a hit where on the lowest sensitivity setting, recall falls down to about 1%. Precision is still in the same range as it was before, but recall takes a hit across the board. So overall, what they found was that the vast number of methods being predicted by this model were really short methods, because once they excluded short methods, the recall was really tiny. It was around 1 or 2%. So it's kind of a negative result in that this didn't turn out to be super useful, but this is still an interesting direction to push in for further work. So that was a quick look at some very initial work that tries to take the idea of autocomplete from just the next symbol or next few symbols up to the level of an entire method. And while the results were not great, the overall direction seems to be quite promising. I hope you enjoyed that, and I will see you next time. Thank you very much.